we've seen a number of methods that either transform or act on our RDDs. But suppose you want to track a value that's only tangential to the actual computation, such as the number of errors encountered during the iteration due to misformatted data, or something of the like. You could return a tuple with both values, but you might consider this a muddling of your code. Don't worry, Spark has this case covered through what they call accumulators, which are shared variables to be used across the cluster. As a quick aside, there's one other type of shared variable called broadcast, but we'll cover them at the end of the course as part of the performance improvement section. Now, accumulators are actually fairly simple. They can be created by calling the accumulator method on the Spark context. This method accepts an optional name used only for tracking purposes. It starts with a 0 or identity value appropriate for the accumulator type used. Out of the box, Spark supports double, long, and collection types for accumulators, providing a contract, accumulator v2, which allows you to create an accumulator type of your own, as long as it follows the associative property. We'll see why that is shortly. We can then take our accumulator and use it directly inside of our RDD methods to increment as best fits our algorithm. Then, after the RDD action has completed, we can use the accumulator's value property to extract out the final accumulation. This is why the accumulator has to follow the associative principle. The additions can be run independently in each worker. Then they'll be associatively combined on the driver to find the end result. You may have already noticed, but the creation and reading from the accumulator can only happen on the driver, while the writing to it can only occur in a worker task. The other important piece of information to remember with accumulators is that they're only guaranteed to be accurate if used within action methods. This is due to the fault-tolerant nature of Spark. Suppose that we do add to an accumulator in a transformation, and the accumulations occur on each worker, passing their respective values down to the driver, so it can combine them together. Now, disaster strikes. Before the RDD graph can complete, one of the nodes that already reported its accumulator value goes down. Well, Spark can no longer track a dead node. So, it spins up a new worker, which triggers a new accumulation during the RDD recreation, which is passed down to the driver, and now our accumulated value contains a double count. This could even occur if the RDD is cached and the cache falls out due to LRU eviction, least recently used, not just from a node failure. Now, all that being said, you're technically allowed to use accumulators in transformations, but they're only suggested for rough debugging purposes. Actions are able to guarantee that their accumulations will only occur once, as they're the last point on the RDD graph. So even if a worker goes down after it sends its accumulator result, it won't need to be recomputed for that graph, as it's already considered complete. Another point to consider if you're going to use an accumulator inside of a transformation is to recall that transformations are lazy. So if you never act on the RDD with the accumulation, then the value on the driver side will remain 0. This is a common mistake that people new to Spark make. Due to these restrictions, I found limited use cases for them. However, one commonly referred to scenario is to count the number of errors encountered during an action. You could then put some sort of error threshold in place to decide whether to save the results or fail the job.